Given that B is the midpoint of AC and AC is perpendicular to BD, prove that triangle ABD is congruent to triangle B or CBD. So first, let's look at what I want to prove. Triangle ABD, so this triangle here, needs to be congruent to CBD for this triangle here. I'm told that B is the midpoint of AC, which means that AC is cut into two equal parts, and that AC is perpendicular to BD, so that means that these two meet at a right angle. The only other thing I need in this proof is to say that this side here is equal to itself because of the reflexive property. Now, just because we have a right angle doesn't automatically mean HL. Notice, we have no information about the hypotenuse of either triangle, so I have to look at a different reason. How about side angle side? So, let's create our proof. In order to do side angle side, I need to say that two pairs of sides are congruent and one pair of angles. So let's start off with our givens. B is the midpoint of AC, and AC is perpendicular to BD. I'll start with the midpoint. Since M is B is a midpoint, AB has to be congruent to BC because of the definition of midpoint. Now I'll use the perpendicular. Since AC is perpendicular to BD, that means that the measure of angle DBC equals 90 degrees. And the measure of angle DBA also is 90 degrees. That would just be because of the definition of perpendicular. Step 4, I'll go ahead and say that these angles equal each other since they both equal 90. Since their measures are equal, they also have to be congruent. So I have one pair of congruent sides, one pair of congruent angles. So I need the second pair of congruent sides, which would just be BD is congruent to BD because of the reflexive property. This reason was just the definition of congruence. So now that I have all three parts, I can say that the triangles are congruent because of side angle side. Triangle ABD is congruent to triangle CBD.